Welcome to Learn Instrumentation Engineering. In the previous video, we have discussed about the pressure measurement devices, in which we have covered the different types like gravitational gauges, deformation gauges, and in this video we'll be checking out how the transmitter and transducers work and what is the difference between both. So hope this video will be very useful to you, so keep tuned for this channel. Okay, today we are going to discuss about important subjects, transmitter and transducer. Even a skilled instrument engineer have a lot of confusion over this transducer and transmitter. Basically, transducer is a device which converts one form of energy into another form. Like it may convert a mechanical energy into an electrical energy. And what is transmitter? This transmitter has inbuilt transducer which converts a mechanical energy to an electrical energy, and additionally this transmitter transmits the electrical or voltage to a remote controller. So this is how a transmitter works. There is a difference between a transducer and transmitter. In the transducer we have two different elements. One is a force summing element and the other is a sensor. So how does transducer work? This force summing element may be a diaphragm. So when a pressure or force is exerted over the diaphragm displaces. So it displays as a measurable displacement. And the next one of the transducer is the sensor. So this is a very important element over here. So the sensor, what happens? It just converts that diaphragm displacement into an electrical output signal. So this is how a transducer works. Okay, this transducer and transmitters having a lot of sensor types. So what are those sensor types? Bonded strain gauge, potentiometer element, oscillative element, and piezoelectric gauge. Though we have different types of elements, mainly transducers uses strain gauge. So we'll see how the strain gauge works. So you could see over here, when the pressure is exerted in the bottom, that's a strain gauge sensor, and that create a stress, and that compresses, and that compressment is converted into an electrical signal. This is how a strain gauge works. And next is the potentiometric element. So how does it work? Basically, you could see the pressure sensor senses the pressure, and it converts that pressure, that force, that displacement into the wiper arm, and that wiper arm is connected to a resistance. So when there's a change in resistance, it is again converted into an electrical output signal. So this is how a potentiometric element works. That's very simple. We all know that potentiometer is basically a change of resistance, right? Okay. And next is the piezoelectric gauge. This is also being widely used. So how does this work? Basically, piezoelectric gauge uses quartz crystal element, so that creates electrical voltage when a force is applied over there. We have a capacitance and resistance in parallel, and it gives the voltage signal output over here. And what is the main advantage of this piezoelectric gauge is that it measures rapid change of pressure in a very short duration of time, and that's a very big advantage of this piezoelectric gauge. Okay guys, now we have seen the transducer and different types of sensor and how they are working over here, and now we will be checking out the transmitter part. We have different types of transmitters, analog and smart transmitters. Globally, a lot of analog transmitter is being replaced by smart transmitter because of its more added advantages due to its microprocessor based element. So let's see what is available in a transmitter and how it is getting converted into an electrical signal. Yes. So this is the main block diagram of a pressure transmitter. We have a pressure, and that is being sensed by a sensor. That's a pressure element. And then it gets into a transducer where a signal conversion happens, and then it gets amplified either into 3 to 15 psi for pneumatic transmitter, 4 to 20 milliamps for analog transmitter, and a small transmitter. Somewhere it gets into proprietary digital like feed bus also. So this is the main block diagram of a pressure transmitter. and we will see how an analog type transmitter works, because most of the industries are not using analog type. Let's have an idea over it, over the function of this analog transmitter. So basically, analog transmitter uses a strain gauge. The direct conversion of pressure into an electrical signal is accomplished here by the strain gauge. Is when the strain gauge gets actuated, the change in the resistance of the V-stone bridge causes a change in the transmitter's amplifier's output. So the amplifier output of 4 to 20 milliamps output signal is sent back to a receiving device such as a controller. Okay, so the same output is sent to the feedback resistor. You could see this. So why this is happening? Just to balance the Wheatstone bridge, and that gives a main thing is stability is getting established over here. So this is how an analog transmitter works. And now let's see the smart transmitter, which is now used everywhere over the industries. So here you could see there are two modules, only the sensor module and another is the electronics module. In the sensor module we have a sensor, and basic that measures the process parameters, and then that sensor converts the signal into an analog to digital conversion. And we have ambient variable sensor, like we may measure the temperature, static pressure, etc. And once this happened, it gets into a sensor interface, and then it gets into the electronic module. So basically this is a very heart of the smart transmitters, the electronic modules. Here is where we have the microprocessor controller. I will detail the different function of a microprocessor later, but let's see what are the functions available over here in the microprocessor. We have a categorization, range of diagnostics, user configuration, database and conditioning, and finally it does the compensation. After doing all these function, it does give the output. It can give you output of 420 milliamps or to any digital signal to the control room. So this is how the microprocessor smart transmitter works. And basically the sensor technology we are using in the smart transmitter widely is a capacitance drive. So how does capacitance drive work? It's very simple. You could see in this figure we have two isolating diaphragm, the left and the right, where we give the pressure. This is a differential pressure transmitter sensor. That's why we have two different pressure in the left and the right, and we have the sensing diaphragm in the middle, which is movable, and there are two capacitors, the stationary plate which is very fixed, and it is being filled with the silicone fill fluid. Okay, right. So when the pressure is applied in the left side, it might be in a high pressure side, and the right side is the LP leg, it's maybe a low pressure side. For example, if the pressure is if you go the high pressure in the left side of this isolating diaphragm, there's a HP. The isolation diaphragm displaces, that causes the silicon fluid to exert, or minutely the sensing diaphragm get deflects towards the low pressure, and this minute displacement is converted into an electrical signal. This is what happening in the capacitance sensor, and already we know that it gets converted into analog to digital signals, and then a signal interface, and then it goes to the electronic mode of a microprocessor. So this is how the capacitance drive sensor works. So today we have discussed detailedly on the transmitters and transducers. So how does a transducer work? What are different elements in the transducer? And how the analog and smart transmitter works, what are different modules available over there. So basically transducer is being used in submergible pumps, like a pressure temperature transducer. They are used in compressors, and if it's like any skid type, they use mainly the transducer. Okay, and this transmitter is being widely used in other parts of the industries. It may be used in separator, piping, and other areas. So today you have learned about the transmitter and transducer. Hope this video was very useful to you, and if it's really very useful, just hit the like button and share to our instrument community. And if you want to watch such instrumentation videos, keep subscribe to our Learn Instrumentation Engineering channel. Thank you.